Welcome back. Today we're going to take a look at some additional object concepts, kind of building on what we did in Monday's lecture. So let's get started. We're going to go into those terms block and scope again, and we're going to go into a little bit more detail. We're going to introduce a new idea called overloading, and we're going to talk about overloading methods and classes. We're going to learn how to avoid unnecessary ambiguity, how to create and call constructors that have parameters, how to use a reference called this. Then we're going to go more into static fields. We're going to talk about automatically imported and pre-written constants and methods that we can use in our programming going forward. Then finally, we're going to look at using composition and nesting classes. So let's get started. First, let's look at blocks a little closer. We've talked before that a block of code is what appears within the curly brackets in any given section, but they can exist entirely within another block or entirely outside of and completely separate from any other block. So the only rule is that your blocks cannot overlap. There are three types of blocks. There's an outer, an inner, or a nested block. Outer blocks or outside block is going to be the outermost set of curly brackets. So think of that class block with all the other blocks inside, okay? The inside block or inner block is going to be any of the sets of brackets that are the first indent in when we program. Okay, if we're looking at that class block, all those methods that we wrote, including the main, would be considered inside blocks. We say that these inner blocks are nested inside that outer block. They're contained completely within that outer block. Blocks are going to give indication of the scope of certain items, such as the variables. The scope is the portion of the program where the variable is going to exist, okay? And it can be accessed. We say that variables can come into scope and they can go out of scope. They are created and come into existence when it comes into scope. And they basically no longer exist when they're out of scope, so you cannot use them. Once a variable is out of scope, you need to redeclare the variable in order to use it. Okay, you cannot reuse variable names within a block. If you have two variables with the same name, the computer is going to get confused and not know which variable that you're talking about. So to prevent this, it's going to create an illegal action and a syntax error. There is one exception to this, of course. So the exception is that you can use the same variable names in different blocks, okay? But that block only knows that instance of the variable with that name. So let's look at this example so that we can see what that means. You can see here that you have a variable called a number. Okay, it's used in that main at the very top in the first method. It's also used in the first method called first method, and it's used again in the second method. Each of those instances has its own memory location reserved for a variable called a number. Okay, they're not referring to the same variable. They're not referring to the same memory location. This is called overriding. The variable defined in that block that's currently being executed will always be the variable that is called, okay? We say that the local version of the variable is shadowing all the other variables that are in other methods. To avoid a lot of confusion, programmers do just opt to not reuse variable names within classes. I tend to not like to reuse variable names within a class no matter what, just for my sanity and for those that come after me. So let's take a quick look at an example of this from our book. Again, we're going to work through the you do it sections in the book as a group. So let's get to it. This first one is going to demonstrate scope. And we're going to create a method with several blocks, okay, to kind of demonstrate what that scope looks like. So we're going to start with a new class. New class. Okay. I don't want it there. I want it here. New class. Okay. I am going to call this class demo block. Okay. I do want to go ahead and put the main in there, so let's go ahead and hit that and hit finish. Again, I'm going to make it the way that I want it. One of these days I'm going to figure out if it'll do it automatically, but today's not that day. Okay. Let's first add a statement that's going to just kind of display what we're doing. So system.out.println, okay, demonstrating block scope. Okay. Don't forget your semicolon at the end. It's usually where people get a little, like, you know, frustrated, I guess. Okay. So on a new line, we're going to declare an integer, and we're going to call it x, and it's going to be equal to 1, 1, 1, 1. Okay. Something nice and easy to remember. And we're going to go ahead and print it out. So system, and we're going to say in first block, x equals, let's do that concatenation. Okay, outside of the double quotes, we're going to put the x and put the close bracket and then the semicolon. Okay, now what we're going to do is we're going to create another block. So to create a block, we do those curly brackets. Okay, so we could just do it right here no matter what. In this block, we're going to do a new variable, another int. We're going to call it y, and it's going to be 2222. Okay, now we want to then print them both out. So system.out.println in second block, sorry, x equals concatenation with the x, and do the same for the y. Plus y. Oops. Man. Okay, stop. There we go. Okay. Now, on this next line, we're actually going to put a third block. Okay, so go ahead and put your curly brackets. Okay, would you actually ever do this? Probably not. We're just doing it to show the blocks and the scope, okay? Now, in this, we're going to declare an integer. We're going to call it y now. 3333. Okay. We're going to print all out. In third block, x equals plus x. Okay. We're going to say y equals plus y. We're going to put a method here. So demo me method. Oh, demo method. METHOD with nothing. Okay. Then we're going to go back and print x and y again. So system.out.println. After the method, x equals what? Okay. And we're going to do the same thing for after method, y equals plus y. Okay. Now, what we're going to do is, after both of those closing brackets, we're going to put a print here, and it's going to say at the end, x equals plus x. Well, that didn't work. So, plus x. Okay. So we've got 3 blocks. We've got the public static void main. We've got 1 block where it's the 222, and then another block where it is the 333. Okay. Now let's go ahead and do that demo method. Okay, so public static void demo method. Remember, no semicolon because it is a method. In here, we're going to say int x equals, let's see, 8888, and y equals 9999. Okay, so again, we've got an x and a y. We're setting it to 8888 and 9999. Now let's go ahead and print x and y. So, system out print line in demo method x equals concatenate the x. That's not it. There we go. System.out.println in demo method y equals plus y. Okay. Now, we've got that final closing bracket for the method, and we've got the close of the class. Now, let's hit save. Okay, I figured out what I did wrong. We don't want to nest these blocks. We want these blocks to be like this. There we go. I believe that's going to correct my error. There we go. Okay. Sorry about that. So demonstrating block scope, that's standing here. So int x, we're going to print out and we're going to get 1111. Okay. We go into this first block. X is still 111 and y is 2222. Okay. There we go. Okay, so you have it printing out 1111, 2222. You come out of this block, this y ceases to exist outside of that curly bracket, okay? So we have a new curly bracket, we could declare a new int, and we say x and y. There it's going to be 1111 and 3333, so 1111, 3333, okay? Goes down into demo method, okay? A new set of curly brackets. Now, since we're in a method, it knows nothing about what's going on in the method before it because you didn't send it any parameters. So you have a new x and a new y, so it's going to print out 8 and 9. So in the method, it prints out 8 and 9. Okay? You go back up to where it was called from on line 21. And you see here after the method, x and y, it's still going to be your 1 and 3. Nothing has changed by coming down here and going into this method. So you still have 1 and 3. And then at the end of everything, x is still equal to 1. Okay? Since x is within the parentheses between lines 5 and 28, it exists the same in all of that. The y declared on 12 only exists until 15. The y declared on 17 only exists until 25. And these two only exist until the end of that method. And this method on line 30 knows nothing of any of the variables happening in main. So hopefully that shows you a little bit more about block scope. So this class employee is considered to have an overloaded constructor, okay? Notice there's one that takes an integer, num, and then there's one that doesn't take any parameters. Okay, remember, since we did this first one where it says int num, Java does not give us the automatic empty one, so we want to put it back. Okay, so we explicitly put it back in this example. Now, when you go to create a new employee object, you can do it with a number or without. If you do it without a number, it's going to set that employee number to 999. Okay. Because there's two constructors, it's considered overloading the constructor. Okay. The same constructor identifier, okay, it's going to have a varying number and type of parameters. Okay. Just like what we talked about. If you have these two different constructors, there is no question which constructor you're calling. Okay. Because there is no ambiguity in this. If you call it with a number, it's going to, with an integer, it's going to do the first constructor. If you do it with no parameters, it's going to do the second. Okay, let's go back to the code that we started just a second ago, and let's look at overloading the constructors. Now let's work with overloading methods. So what we're going to do is we're going to create overloaded methods to display dates. So the date displaying method is going to be, can be used by different applications over different organizations for different purposes. So what we're going to do is we're going to start out with a new class. So class, we're going to name it demo overload. Okay. We want a main. Go ahead and click on finish. Now, again, I'm going to arrange these the way that I want them. Beautiful. Okay. Now, let's start here with some variables. Okay, let's make an int. We're going to say month. Let's say 6. Oops. Let's say day equals 24, and year is going to be equal to 2021. How's that? Okay. We're going to create 3 different methods. So let's say display date. We're going to send it month. We're going to create an overloaded method. So it's going to say display date, and we're going to give it month and day. And then we're going to have a third version of display date, and we're going to send it month, day, and then year. Okay. So let's go down here and we're going to do our overloaded methods. Okay, so let's work on the first one. So public static void display date. Okay, the first one's going to take the int and it's going to say it's going to be the month. Okay, remember no semicolon because we're using curly brackets. And we're going to say system.out.println event date. Okay, we're going to say month, and then what we're going to put after it is just 1-2021. Okay, that's all it's going to be. So the only thing you're going to be able to change if you use that one is the month. Okay, now we're going to create the second overload, or well, I guess the first overload method, public static void display date, and this time we're going to take an int month, but we're going to take an int day. Okay. Go ahead and put our brackets. Now, what we're going to do is we're going to do another print. Okay, event date space, and we're going to put month plus the slash plus day plus slash 2021. Okay. And then lastly, we're going to create, again, using the same method name, public static, void display date. It's going to take an int month, int day, int year. Okay? And this, you know what? I'm getting lazy, so let's only copy, paste. Oh. Yay. Okay, so what I'm going to do is instead of that right there, I'm going to say year. Okay, so for this, what it's going to do is on this first one, it should display 6/1/2021. Okay, for this one, you're sending it as 6 and 24, so it should say 6/24/2021. And let's change this year so we know it's like working. There we go, 1900. Sounds good. Okay, so here it should say 6/24/1900. Okay, and let's get rid of that. Save and run. Okay, so 6/1/2021, 6/24/2021, and 6/24/1900. You can see how it knew exactly which method I meant due to the parameters being chosen. So if it was 1, it was the first one, 2, and 3. So it knew exactly what I was talking about with these overloaded methods. Now, as programmers, we want to eliminate ambiguity whenever possible. So ambiguity is going to happen when the compiler can't determine which method to use. So if there are multiple methods with the same name, what you can do is you can differentiate between these methods by using different parameter lists. So say you have 2 methods and you call them both sum. Okay, maybe one takes 2 doubles as parameters. The other one could actually take 2 ints. That's okay. This actually is going to create 2 completely different methods with exactly the same name. Okay, so it's going to work the same whether you send it 2 doubles or 2 ints, but they are considered different. Creating these different parameter lists is called overloading the method. Okay, you can create multiple methods with the same name, but you have to vary the number and type of parameters in order to tell them apart. Okay, if there are identical method names with the same number and type of parameters, it's going to be considered ambiguous again, and illegal. Okay, even if they return a different data type. Okay, it's not based on the return of the method, it's based on the parameters being sent to the method. Okay, so it's not going to be concerned with that return statement. You could have 2 methods that both take in 2 doubles, but one returns a double, one returns an int. That's illegal. Okay, what makes it legal is you change the parameters. Let's take a closer look at creating these overloaded methods, okay, and their constructors. Remember, Java is going to automatically create that empty constructor for you, okay? That's going to be that constructor that has no parameters required. We talked about how you can write your own constructors last lecture and how we can use things such as the parameters to initialize default values, right? But whenever you create any type of constructor for a class, you automatically get rid of that automatic constructor that Java builds, okay? So if you want to have that empty constructor, you need to put it back in. Okay, so let's take a look at some code, okay? One other thing is that you can have a constructor for a class require an argument every time the object is created. Okay, so maybe you don't want the empty one. Okay, so let's take a look at some code and see what this looks like. Let's do an example now of the overloaded constructors. So we're going to create a class with overloaded constructors and we're going to demonstrate how they work. So we're going to do a new class. We are going to call it car insurance policy. Okay. We don't want a main in car insurance policy. Okay, we're going to actually have another class that's going to be our main. So car insurance policy, no main, we're good to go. Okay, let's start with some variables. Let's say private int policy number, private int number payments, private string resident city. Okay. Now remember, we keep them private, and in order to change anything to them, we need to do gets and sets. Okay, or we use the constructors. So let's start with some constructors. Okay. Let's start with a public constructor so that everyone can use it. Car insurance policy, and we're going to send it an int for the number. We're going to send it an int for payments, and we're going to send it a string for the city. Okay, that's going to be the most complete constructor because we're going to be setting all 3 of those variables. So now we just want to say policy number equals number. We want to say number of payments equals payments, and we want to say resident city equals city. That's the first constructor. Now, suppose that one of their common cities is Mayfield. Okay, so we want to do a constructor where they can enter a number and payments, and the city's going to automatically go to the default. So let's see, public car insurance policy int number, oops, that's not a word, int number, int payments. Okay, here's going to be our first overloaded constructor. Okay, so what we want to do is we could do it a few different ways. We're going to look at this later on, and that's going to be a good way to do it. But what we want to say, we want policy number equals number, num payments equals payments, and resident city equals Mayfield. Okay. Now let's thirdly add a third constructor. So let's do a constructor that says everyone's going to pay into payments in Mayfield. So public car insurance int number. So all you need for that constructor is the policy number. Okay. Now policy number equals number payments equals 2. Resident city equals 2. Mayfield. Okay. We want to add one more method to this, and we're going to call it display. So public void display. And it is always good for your classes to have a display which is going to format the information that's held within it the way you want it to be. So system.out.println policy number, policy number. Okay. Num payments annually. Driver resides in resident city. Okay. And actually, let's make it a little better than that. So plus whoops, Beautiful. Okay. Let's go ahead and hit a save on that one. Now, what we want to do, I'm going to create another class to go ahead and call this. I have something wonky going on here. Oh, I have an underscore. There we go. Okay, beautiful. Okay, new class. I am going to call this one create policies. This one is going to have a main, on the other hand. So let's go ahead and start that one. Okay, now we're going to say car insurance policy. Okay, we're going to create the instance of it. First equals new car insurance policy. Okay, now the first one we want to send it, we're just going to send it the number for a policy number. Okay, then let's try the second one. Equals new car, insurance policy. Okay, we're going to send it a number of 456 and 4 payments annually. Okay, let's do a third one. New car insurance policy. P-O-L, that's not spelled wrong. I-C-Y. There we go. Okay, of 7, 8, 9, 12 payments, and they are from Newcastle. Okay, now what we want to do is we want to display each object. So first dot display, second dot display, and then third dot display. Okay. Now let's see what happens when we run this. Okay, so the first one should be a policy of 123 with 2 annual payments because that's our default constructor, and it should be Mayfield. So let's look. Policy 123, 2 payments annually, driver resides in Mayfield. Now the second one is the policy number and the number of payments. So it should be this one right here on line 17. So it should be 456 with 4 payments, but they're still in Mayfield because that's what you're telling it on line 21. The third one on here on line 10 is going to come back and call this one over here on line 10. And it's going to say number 789 with 12 payments and that the driver is in Newcastle. So you can see how each one of them, again, it's not the return, it is how many parameters that you are wanting that is going to determine which constructor you're going to use. Next, we're going to talk about this. This is a reference used in Java to identify what you're talking about explicitly instead of doing an implicit understanding of what you're talking about. So, okay, this means exactly what it sounds like. It means this object or the current object you're in. Now, it's not discussed this way in the book, so you might want to make sure you take some notes. I'm not sure I really liked the explanation in the book. I like to see it in examples, and it makes a little bit more sense to me. So it uses a lot of vocabulary, but let's look at this in action. Let's trace through this code. So we're going to start in the main on the right-hand side. Okay, you create a new test object with the numbers 10 and 20. So it's going to look at the constructor. If you look at the constructor on the left, it says this A equals A. Okay, so the class variable A will be set to the value of 10. The same goes for that class variable B. The class variable B, this B, is set to B. Now they used A and B as the 2 parameters, okay, and then they used A and B as class variables. Okay, so you can see where they've double dipped there, and so therefore this is going to give it explicitly which this you're talking about. It's going to go back to the main. It's going to do object.display. Okay, so it's going to go up to that display, and it's going to display A equals 10, B equals 20. Okay, but the this on the left is saying that the this is the object A and B is going to be set equal to the method A and B. Let's look at another example. You can also use this for constructors. So in this example, there are 2 different constructors. Okay, there's a default constructor and there's a parameterized. That's a terrible word. Constructor. Okay, the parameterized constructor is exactly what we just looked at. Okay, the default constructor calls this with the values of 10 and 20. What that actually does is it's going to invoke the constructor that takes 2 parameters that are integers. So it's going to actually invoke the parameterized constructor that's on the right. Okay, so let's look at the main. The default constructor is going to be called test object equals new test, open and close parenthesis. That's going to call the default on the left. Okay. The default is calling this with a 10 and 20. That's actually going to send it back to the right. This A equals 10. This B equals 20. So what it's going to do is it's going to print out first inside parameterized constructor. Then it goes back to the right and it'll say inside default constructor. Then it's going to complete. Okay, so you can also use this to call a constructor within the class where that other constructor exists. Okay, it's kind of a neat way to reuse your code. We're going to look a lot more into that in a little bit. The last example that I have here is, there's so many other uses other than just these 3, but these are some of the main ones that we like to use it for. Here, this is used to return the current class instance. Okay, so you're going to look on the left, return this. It's going to return an object of test. Okay, so let's look at the main. It uses object new test. Okay, nothing different there. Object.get.display. Okay, the get portion of that is what is going to return a test object. Okay, within that test object, it wants to go to the display. Okay, so that's how you can also use this to return the actual object that it is within. Again, there's so many other uses of this. It can be used as a parameter for a method. It can invoke the current class's methods. It could be used as an argument in the constructor call. But again, these are some of the typical ones. This is a reference to the object's memory address, okay? So in some instances, it can be automatically understood without actually having to be written that way. So these two methods, get employee number, will operate exactly the same. One's going to say return employee number, the other one says return this employee number, okay? The implicit this is in the top one, okay? The explicit is in the bottom. In this instance, this was only added for clarity, but they're both actually going to operate the same. So this is not always needed, but it can be added for clarity. That last, the middle example that we looked at this to overload your constructors, okay? Overloading your constructors actually makes your code more efficient. It avoids repetition within the constructors, and it alleviates some messy errors that you can kind of miss. So here are two classes. They're both called student. Okay, they're both correct. They both run fine. One's not right, one's not wrong. Okay, they're both going to do the same thing. The version on the right is going to be more efficient and less prone to errors. So let's take a look at it. On the left, there are assignments being done for each constructor. Okay, so each variable is assigned within each constructor. Okay, so that step is repeated 4 different times. Okay, on the right, the assignment is only done in one constructor, the constructor that has the int and the double. The other 3 actually call this with the numbers and the values it wants it to be. Okay, so what you're doing is you're passing it those changing variables when you use your this. Okay, on the right, if there's a change in one of those variable names, you only have to change it in that one constructor at the very, very top. Okay, on the left, you would have to change it every single time you assigned it, so you'd have to change it in 4 different places. You could see how that increases the possibility that you could actually miss one of those places and create an error. So let's play with our example one more time. We're going to change this over to use this reserved word. So what I want to do is, let's go to car insurance policy. We're going to do a save as, and we're going to call it number, say policy 2. Okay, so I have to put 2, 2, 2, and 2. Okay. Beautiful. Okay, now it's very easy to change this over to using this. So the constructor between lines 10 and 15, nothing's going to change. Okay, they're going to change in the one on 17 and the one on 24. So what you're going to do is you're going to get rid of those 3 lines of code, and you're going to say this. What that's going to do is you're going to give it 3 parameters, so it's going to bump it up to the constructor on line 10. So what you want is the number of payments, and then you want Mayfield. Okay? The same thing's going to happen for the constructor on 22. Okay? You want this, you want number, you want 2 payments, and then you want Mayfield. Okay. You can see how it's kind of shortened down the code a little bit, and you're not having to constantly type everything over and over and over again, okay? The display is going to remain the same. Nothing's changing there. So let's go ahead and save that. Create policies. Let's go ahead and do a save as well on that. We'll create policies. Let's call it number 2. So we'll keep them separate. Let's go ahead and add our number 2 to the top. Now, we want to use the car insurance policy too. So let's do this. No pun intended. There we go. So all I did was change it from the car insurance policy to the car insurance policy 2. Everything else remains the same. I'm going to go ahead and clear out this console window to make sure that everything does change the way that we think it's going to. Go ahead and hit the run. Now again, we've got the 1, 2, 3, 2 payments, Mayfield, 4, 5, 6, 4 payments, Mayfield, and then 7, 8, 9, 12, and Newcastle. So it operated exactly the same. And the only thing that you changed was this line 19 and this line 24. So we removed about 6 lines of code and we only put 2 back in. So you can see how now it will be a little bit more efficient and it's a little bit easier on the programmer. Let's revisit looking at static again. So in class methods that don't have any this references, or if they don't have any objects associated with them, you should use static. With variables, on the other hand, if a variable is shared by every instance of the class, it should be static. Okay, what that means is that even though only one copy of a static variable is available per class, not per object. We talked about constants before, but remember that you add the word final to the qualifier in order to make the variable unalterable after it's constructed. Okay, constants can also be set in the class constructors. One thing to remember is that not all static variables need to be final, and not all final variables need to be static. So let's go look at another example. New example again. Now what we're going to do is using the static and non-static and those final fields. So we're going to create a class for a dog club to demonstrate the use of the static and non-static and final. Okay, so what we're going to do, let's create a new class. That's not even what I wanted. New class. Sorry about that. Okay, under the name, we are going to call it Dog Triathlon Participant. Okay, again, we don't want a main in this. We're going to have another class that is actually going to call this one. Okay. First, let's create some variables. Okay, let's have a private, let's say final int num events. Okay. Let's say a private static int total cumulative score equals 0. Sometimes talking and typing at the same time is very difficult for me. Okay. Now we're going to have some more fields. So let's say private string name, private int obedience score, especially when the words I can't spell very well. There we go. Private int conformation score, private int agility score, oops, okay, private int total, and private double average. There we go. Okay, now we're going to do a constructor. Okay, we're going to make it public. Okay, dog triathlon participant. Okay. What we want to send it is we're going to send it a string for a name, an int for a number of events, and score 1, score 2, score 3. Oops, there we go. Okay. Now, one of the things we did is one of the parameter names is named name, and one of the class names is name. So we want to say this name equals name. Okay, that's going to set the variable within the class, in this class, equal to the value in the parameter name. So we're going to do that one first. Then num events, okay, that's going to be that constant. We're going to set it equal to num events. Okay. Obedience score equals score 1. Okay. Confirmation score, score 2. Nope, there we go. And then agility score, score 3. Total is going to be equal to all of those added together. So obedience score plus confirmation score plus agility score. Or you could do score 1, score 2, score 3. Either one works. Your average is going to be equal to, now remember we've got a bunch of ints here, and thinking back to a few lectures ago, an int divided by an int is going to give you an int. Well, we actually want a double here, so we have to cast it to a double. Okay, so total divided by num events. Okay. Total cumulative score equals total cumulative score, I can't spell this. There we go. Plus 1. Oh, plus total. Plus total. Here we go. Okay, beautiful. Again, I want to go ahead and I'm going to put a display in here. So public void display. This is going to allow my object to display it that I want it, the way I want it to. Okay, so system.out.println, and we're going to put name participated in num events oops, and has an average score of average. Okay. Let's do one more. And this is going to say, we're going to do a few spaces to indent it a little bit, and then we're going to say name plus has a total score of total, bringing the cumulative, oops, I can't even say it like that and type it, ATIVE, there we go, score to total CUMULATIVE. Okay, you can tell that I did not make these up because I feel like my variable names would be so much easier to spell than half of these. I'm just saying. Okay, beautiful. Okay, let's hit save. What did I do wrong? I don't know if I can type this word. That should be that. Plus total. There we go. Okay, that should be good. I think. Let's see why it's wrong. It doesn't like me. Why doesn't it like me? Problems. Line 16, delete these tokens. Oh, because I put a space. There we go. It should be happy now. Beautiful. Okay. Sometimes you just gotta compile and see what happens. Okay, new class. I'll put it in my lecture folder. New class. Let's call it test dog. This is where I want my main, so let's go ahead and click on it and for them to do it for us. Okay. Now, in this main, I'm going to create 3 different dogs. So, dog, try, oh Lord, participant dog 1 equals new. I'm going to cheat because this is a big word. There we go. Okay. It's going to be Bowser 285 89 0. Okay. Dog 1 display. Okay. Let's see. Dog 2 equals new. Just control Ving it here. Okay. Rush 3 78 72 and 80. Dog 2 display. And then we have dog 3. Ginger 3 90 86 72. Dog 3 dot display. Okay. Now, go ahead and save that and let's go ahead and run it. Oh Lord. Oh, because I can't spell. Display. Thank you very much. Okay, so Bowser participated in 2 events and has an average score of 87. Bowser has a total score of 174, bringing the cumulative to 174. Now, let's go back to this dog triathlon here. Remember, this one is static, so that means there is only one of those no matter how many objects I create, okay? So right now it should be at 174. Rush is going to be in 3 different events. There's an average score. There's a total of 230. 230 plus 174 is going to give me the 104. You see how that's different, okay? The total is changing, but the total is a private. It's not static, okay? Then we go on to Ginger. 3 events, average score. Ginger has a total score of 248. 248 plus 404 is your 652. That's how you can determine the static. There's only one, no matter how many objects you have, because we have 3 dogs here, but that cumulative total keeps adding to itself, no matter how many instances of dog we have. One of the benefits of Java is the ability to have pre-written code available to all programmers. There are a ton of classes available that programmers are commonly going to use. Typically, these classes are grouped together somehow. This grouping of these classes is called a package or a library of classes. There are 2 types of packages, a fundamental class package or an optional class package. Fundamental classes are implicitly imported into every single program and are available at all times. Optional classes are only available if you explicitly name them in the program. The java.lang package is an example of a fundamental class. It's implicitly imported every time Java runs. This is the only package that is named that is automatically imported. Other classes, though, that we do use include the object class and the capital I integer, capital F float, all of those wrapper classes that we talked about last week. The optional classes must be explicitly named. One example that we've used is the JOption pane, where we had to import the javax.swing at the top. You explicitly have to tell the program to go ahead and load that package that you're getting ready and you're going to use those classes. java.lang.math is a commonly used package. This is the package that's going to contain all of those mathematical functions, constants, and any kind of operation you could think of. You don't need an instance for this class, and it is imported automatically. To actually prevent programmers from creating an instance of an object that is of a java.lang.math, the constructor is actually set to a private. So if you actually try to do this, you're going to get a syntax error. Here are some great examples of methods that are available to you if you import that java.lang.math package. You can do things like absolute value, trig functions. It holds actually a constant that is pi that you can use. You can even find the square root of a number. Again, you can see the power of that reusability in code by not having to rewrite these types of mathematical operations every single time you need to use one. If you want to use any of the classes outside of the java.lang package, you need to do one of the following. You need to do, number one, either use the entire package path with the class name when you use it. You can do number two, import the class by itself, or you can do number three, import the package as a whole where the class is contained. Now, if you want to do that third one and import the entire package, you're going to use something called a wildcard symbol. It's going to be an asterisk. This is going to indicate that you want all of the classes within that package imported. Okay, it is okay to import classes that you're not going to use. It's not going to be any kind of detriment to your code. But if you do import only the ones you need or the ones you use, you can kind of use that as a form of documentation. So let's take a quick look at a class called local date. The local date class is located in java.time. So we're going to use the import statement and a wildcard to import the whole entire package. So see where at the very, very top it says import java.time.asterisk. Okay, that's what's going to import that entire java.time package. So this class is useful. It can be used to get dates. There's no time zone associated with it, so it is going to be local only. There are two static methods to use that we're showing here, and that's now and of. Now, the local date.now is going to give you the current date, and the local date.of is going to create a date from the parameters that are sent to it. You can see in action here that black box that we talked about happening earlier. We don't care about any of the math or the details or how it goes and does the date or how it holds it. We just know we get a date. Okay, local date has also got some useful methods such as like a get month and a get day week. These are going to return something called an enumeration. An enumeration is just a list of values. So get month, it's going to give you January, February, March, April, May, June, you know, the month basically in word form. So let's take a quick look at some of this. For this next first we're going to take a look at the Java API, and then we're going to go into an implementation of it. So using your browser, you can go to the link in the book, except I would put a 15 where the number 9 is, because that is the most current version, okay? That's the only difference. So what you can do is you can go and let's find the local date class. Okay, so we're going to look under java.time. So let's see. Okay, we're going to do this the easy way. Oops, that's not it. Oh, okay, I lied. So in search here, what you can put is local date. Okay, so here, java.time, local date, we can select it. It will take us directly to the class for local date. Now, it does tell you which package that local date is in. Notice it's in java.time. It has some great information about just the background and the history and why we have it. You can also look down and find where, you know, what fields are there. You can find what methods. You can differentiate between static methods and instance methods. You can also see here some of your overloaded. So here at time, you've got an hour and int minute, or you have hour, minute, second, or you have hour, minute, second, nanosecond. Again, they're all at time. And here, there's two more, a local time and an offset time. So you can see that a lot of these classes that are in these packages actually do use the overloading. So here's some of the other ones. You know, we've got minus is used several different times. There's some fields. Here's some method details. And it goes into what it does, what the parameters are, what it returns, whether, you know, it throws an exception. But there's lots of great information in here on this Java API. But let's get to what we wanted to do. We're going to use an explicitly import and pre-written class. Okay, we're going to go ahead and use that local date and time. So what we need to do is we're going to do a new class. We are going to call it timed response. Okay, we do want a main in it, so let's go ahead and just click on that. Okay, now if we want to use that local date, we have to import java.time. Okay, .star. There's our wildcard. We're just going to go ahead and import all of the classes that are in java.time. Now this one we are actually going to use a little GUI going on, so let's import our Java Swing, our J option pane. And here you can see the difference between those two import statements. This import statement on line 2 is only going to import the J option pane class from the Java Swing package. The import on line 1 is going to import everything out of the java.time package, okay, and allow you to use it. Okay, let's get into our main. Okay, let's create some new objects. So local date, time 1, oops, don't do my spaces again, time 2. We're going to make some ints. Seconds 1, seconds 2, and then difference. Okay, these are going to be some of my variables. Oh, if I could spell time. There we go. Wow, so many typos today. My bad. Okay, let's assign the local, so let's assign local time to the time1 object. Okay, so time1 is going to equal new, nope, lied, local date time, not on two different lines, local date time dot now. Okay, that's going to give it the local time right now. Okay, now we could say seconds 1 equals time 1 get seconds. Okay, now let's get into our GUI. So let's do a J option pane, show confirmation, confirm. Why do I always put mation? Dialog. Okay, null is the parent, and then is stealing ever justified? Okay. Now, what we want to do, let's get the time immediately after the user presses the button. Okay, so time 2 is going to be equal to local date time now. Okay, seconds 2 time 2 dot get second. Okay, do you see what we're doing here? We're getting the time before the GUI is displayed, And then we're getting the time immediately after the user presses that button. Okay. Now, we're going to calculate the difference in times. Okay. So, difference equals seconds 1 minus seconds 2. Okay. Next, then finally what we're going to do is we're going to go ahead and basically tell the person how long it took them to answer the question. Okay. So J option pane, show confirm dialog. Oops. Null. Okay. End seconds 2 plus. Okay, we're going to do a /n for a new line. Remember, we're in a GUI window now, so let's do a new line. Start seconds plus seconds 1. New line. It took difference seconds for you to respond. Okay? Now let's see what happens. Home. There we go. Save. Let's run this sucker. Okay. I have to move some windows around. Is stealing ever justified? Yes. Okay. Why? I don't know. Okay. It took me 1 second for me to respond. Okay. Let's try one more time. I'm going to take my time on this every so often. So let's see if my end seconds changes. There we go. My end seconds is 20. What did I do wrong? I did something wrong. Because my end seconds and my beginning seconds are the same. Hold on. Seconds 1, seconds 2, difference. Oh, my difference is going to be 2 minus 1 minus 1. Y'all, we're not in lab, like, doing this together. You guys can't call me out for my silly mistakes. It's hard. Okay, let's try it again. No, it's because I said yes that first time. I'm telling you, that's what it is. Okay, so I started at 10 and I ended at 14 and it took me 4. So this is using basically those import statements for your packages and a little bit more of a GUI work. Composition describes the relationship between classes when classes might be data fields of other classes. So just as variables are in an is a relationship, remember we said a variable is a type. A class composition, there is a has a relationship. So you say that one class has an instance of another, okay? And don't forget your constructor parameters if you use this composition, if there is no default constructor. Nested classes are classes within other classes. So they're going to be all saved within one file, and you're going to call the outermost class the top level class. So there's 4 types of nested classes. A static member class is a class that's going to have access to all the static methods of the top level class. A non-static member class, or in other words, that's the inner class, that's going to require an instance, but it also has access to all the data and all the methods of that top level class. Local classes are local to a specific block of code only, okay? And then finally, you have an anonymous class, and basically it's just a class without an identifier or a name. Now, my favorite section, is here, don't do it, okay? Don't try to use variables that are out of scope. They just don't exist, okay? They're not going to be there. You can't use them. Don't assume that a constant stays a constant. If you use a constant as a parameter, it can actually change into a variable within that method. So just be careful about your constant. Don't overload your methods by only changing the return type. It doesn't work. You have to change the parameters. So same name, different in number and different type of parameters. Don't think that default constructor is the only available constructor. You can create your own. But don't forget that the default constructor is automatically doesn't exist if you do create your own constructors. And finally, don't assume that wildcards are going to work the same in Java as they do in your operating systems. They only work for importing packages. Hopefully I was able to expand your knowledge just a little more when it comes to objects and packages. So once again, there is a case study to watch along with 2 assignments, the debugging exercises, and a quiz for Chapter 4. All of this will be due by the end of the week. So until next time, happy coding!